Okay, so good afternoon, everyone. From the past 2 to 3 classes, we have been discussing some of the major attacks, which are either the system attacks or the resources attacks. So we had discussed denial of service attacks, and within which we classified few of the attacks based upon the location of the intruder, right? So we had discussed majorly, we had discussed denial of service attacks, and I gave you an idea about what is happening in a DDoS attack, that there are probably multiple number of attackers which are attacking a particular system, right? Also, in the previous class, what did I tell you? I told you about the buffer overflow attack, where it was said that the buffer overflow attack normally happens when the attacker is or a particular normal user's program is accessing a location which is not meant for that particular program. Fine. So what are we doing in a buffer overflow attack is we are trying to find out a particular location, probably a memory location, which can be used to find out the address of that particular memory location. You can use that particular address to launch or to copy a particular section of code, or you can use the return address for of that memory location to execute a function. So the majority of the attacks which we have considered till now are DOS, DDoS, and the buffer overflow attacks. Okay. Any doubt in whatever has been covered till now? I hope no doubt is there. Am I audible? Okay. So I told you one concept which was placing of the defenses in a DDoS attack. Okay. So today I don't have the whiteboard accessible to me. I'll use the notepad and speak very slowly. So please listen very carefully, and if you want anything to be repeated there instead, please notify me. Okay, and or either prompt me in between. So if I would like to give you a proper normal the scope and classification of a DDoS attack. So what are we discussing as of now is DDoS attack, its scope and classification. Okay. So normally we the distributed nature of DDoS attacks make them extremely difficult to trace back. Okay, so why do you want to trace back? To identify which is the actual attacker. So since I said that it is very difficult to trace the DDoS attacks by tracing back, why is it difficult? Because the attackers normally use fake IP addresses or the spoof IP addresses to hide their true identity. So this makes the traceback of DDoS attacks even more difficult. Now, there are security vulnerabilities in many internet hosts which can be used by the intruders and can be exploited. So what can be done is moreover what happens is that the incidence of the attacks that target the application layers are actually increasing rapidly. So what does it mean is that we are normally targeting those protocols which are present on the application layer and using them to exploit the server or to exploit the systems which are there into a particular network. Understood? Now, what are we going to discuss over here is we are providing a classification of a DDoS attack. So here we are doing a classification of DDoS flooding attacks. Okay, so everybody knows what happens in flooding. Flooding there, you always have a denial of service attack. but here we are talking about DDoS flooding attacks. Okay, so when we're talking about a DDoS flooding attack, now these flooding attacks can be done on the basis of a protocol as well. So you can have flooding attacks on the basis of protocols. Okay. Now, when we're talking about protocol level DDoS flooding attacks, you can have two categories for it. Okay. The first category which is there is referred as network or a transport level DDoS flooding attack. Okay. Here till now, what are we going to discuss? We're going to discuss DDoS flooding attacks, but these DDoS flooding attacks are generally happening on the basis of protocols. Okay, so on the basis of protocols, first attack is referred as network or transport level DDoS flooding attack. Fine. Now, most of these attacks are launched using TCP, UDP, ICMP, and DNS protocols. Okay, so what happens in network? Usually you are using TCP, we are using UDP, ICMP, and DNS protocols. Okay. Majorly those protocols which are there, those protocols which are part of network and traffic. So whatever traffic is flowing into the network and causing a DDoS attack, it would normally have TCP, UDP, ICMP or DNS packets when you're categorizing it as a network or a transport level DDoS flooding attack. Okay. Now, whenever these types of attacks or these type of packets are being flown into the network, you will have four subcategories of such attacks. One would be, it can either be a proper flooding attack. Okay. Second thing, it is referred as a protocol exploitation flooding attack. Third, it can be a reflection-based flooding attack. And fourth, it can be an application-based flooding attack. Okay. Fine. Is it clear till now?
Yes, sir.
Okay. So we'll discuss all of these four in context to these above packets, these above protocols which we have discussed: TCP, UDP, ICMP, and DNS. The first one, which is referred as flooding attacks. What happens in this? Your attackers majorly focus on disrupting the legitimate users' connectivity by exhausting victims' network's bandwidth. Clear? How do you exhaust the victim network's bandwidth? Who is your victim over here? Your server is the victim, or your legitimate user who is trying to access the server, he can also be referred as a victim. Okay, so if you want to write down, you can sum it up saying that the attackers majorly focus here on exhausting or disrupting the legitimate user's connectivity by making the victim network bandwidth non-accessible. Okay, how do you do it? We do it by sending the spoofed or non-spoofed UDP flood or ICMP flood or DNS flood, or let's say we can have a VoIP flood as well. Okay, So if I want to make the points for this, what packets can be flown? Your packets could be spoofed or non-spoofed. Here, what type of packets they are? I already said that these would be either spoofed or non-spoofed. What spoofed and non-spoofed packets? These can be UDP floods or they can be ICMP flood or it can be a DNS flood or since you're talking about both network and transport, you can have any other protocol. Let's say it can be a VoIP flood as well. Clear? So this is something which is in generally referred as flooding. Okay. Coming to the next one, which is protocol exploitation flooding attack. Okay. So in this, your attackers exploit the specific features or the let's say bugs of some of the victims protocols in order to consume the excess amounts of victims resources. Okay, what are we doing here? The intruders which are there into the network would exploit specific features of a particular victim. What all features can there be? There would be some implementation bugs in your existing protocols, and if these have been identified, these can be used. I guess we had discussed similar attack. What was it categorized as? We discussed about TCP SYN flood, right? उसमें भी तो यही था कि TCP में क्या था? You have a three-way handshaking. So the bug, there isn't any technical bug, but the glitch over there is that if you do not send the acknowledgement, your connection would not be completed or these will be referred as partially open connections. Okay, so here what are you doing? You are flooding the system or you are flooding, exploiting the resources of the victim by targeting a specific protocol. What protocol are you targeting here? You're targeting TCP. Okay, any doubt? So this would be either TCP SYN flood. The other thing can be, it can be a TCP SYN acknowledgement flood. Clear? You can either flood the network using the SYN, you can either flood the network using the SYN acknowledgement packet. Clear? The other ways can be, I guess you would have heard about ACK and push ACK flood. Where is this? Where are these packets used? ACK and push ACK. Any idea? Have you guys heard about sliding window protocols?
Yes, ma'am.
So these ACK and push ACK are used in that. Clear? The other, it can also be, there's one more packet which flows, that is REST, which is reset or finish flood. Where is it used? Where is the reset and finish packet used? Hey, all of your networking concepts are very deela. You should start reading the basics once again. Where is reset and finish used? Bharat,
Ma'am, in establishing TCP at transport layer.
are you sending RST or FN? Anybody else?
Ma'am, finish used for connection termination.
Yeah, it is used for connection termination. If I say that if you're talking saying that it is used in TCP, will it be a three-way TCP or any other TCP? Are both of these same or will are both of these different? RST or FN?
Different.
These are different. What are these individually used for?
Ma'am, RST is for immediate connection termination,
Okay.
and FIN is basically confirmation from a sender or receiver that the sender is want to finish the connection.
Okay. Are these two used in SSL as well? SSL is what? Any idea what is SSL? Secure Socket Layer Protocol. Is it a network or transport or any other layer protocol? Any idea? Somebody?
It is used for connection between web client and web server over a network.
Over HTTP. You're using HTTPS, no? That HTTP plus secure socket layer provides you the services which HTTPS provides. So SSL is majorly used in connection with the protocols which are there at the application layer, and then it would be combined with the protocols which are part of the below layers. Okay, so you also have this thing which is there in SSL. Clear? So coming back to this, which is protocol exploitation. So you can have RST, FIN, flood in TCP as well, and any other protocol which is used to establish a connection and terminate a connection between the clients. Okay, so the third one which is there is the reflection-based flooding attack. Now, reflection-based flooding attacks normally involves those attackers which are sending forced request. So, how are you sending forced request? Let's say I'm sending ICMP echo request. Okay, that request is sent instead of the direct request to those reflectors. So if I say that the attackers usually send the forced request instead of the direct request to the reflectors. Okay, so in return, what would happen? Those reflectors would send their replies to the victim and exhaust the victim's resources. Clear? So let's say what are you doing is there is one client which is connected to a server, and it is said that there is a malicious party or there are multiple malicious parties which are referred as zombies. Okay, and these are sending the packets which is ICMP echo request to the server. Now, when they are sending these packets, these have the IP address of the client which is there into the system. Okay, so they are sending spoofed packets to the server. Now, when the server would reply, it would reply to that particular client. It would not reply to those hosts who had sent the ICMP request. Okay, that is why it is sent that those reflectors. So here your reflectors would be the server is replying back. So those reflectors send their replies to a particular victim. So here your victim can be client and exhaust your client's resources. Okay, so this is something which is part of your small attack. There's one more attack which is referred as travel. We'll discuss travel later. Okay. Now the fourth one, which is the application based. No, sorry. This is amplification. This is referred as amplification based attack. So as the name says that it's an amplifying, it is something where your request or the response would be multiplied in number and then the effect would be generated. Okay. So here what is done, your attackers majorly exploit these services to generate large messages or the multiple messages. For each message, they receive to amplify the traffic towards the victim. Okay, so for this they have botnets. Okay, now botnets can either be used for reflection as well as it can be used for amplification purpose as well. Now, when we're talking about reflection and amplification, we had said in reflection we can use it for smurf attack, where the attacker sends the request with these spoofed source IP addresses to a large number of the reflectors by exploiting IP broadcast feature of the packets. So, if I am talking about, let's say you want a packet to be routed to a particular destination, or you want to find out a particular client who is there onto a network. What would you do? You would try to broadcast that this is the message which has been received and it would be sent to a particular destination. Okay, we will not directly always know what is the actual path or where is the particular client located. In that case, you have to use those routers which are broadcasting a particular message. Okay, so if you're using a broadcasting IP message, in that case, the amount of the what should I say, the scalability of the messages or the strength of the messages increase. So there would be multiple copies of a particular message sent, or there would be multiple clients who would receive that particular message. That is where you can have a amplification based flooding attack. Okay. Now, in case of a normal network or what say network traffic, sorry, network or transport level DDoS attack, we classify all of these attacks on the basis of these four categories which we have considered. Okay. Now we would find out those protocols or those attacks which are established other than the network or the transport level. So the second base which can be there is on the basis of your application level, DDoS, flooding attacks. Okay. Now here, what are we talking about? Here the application level DDoS attacks would normally consume, will they consume higher bandwidth or will they consume lesser bandwidth? In the previous case, which was a network or transport level, we always said that the flooding would be caused due to these protocols. So if I try to compare the data which is or the traffic which is flown from both of these levels, normally the amount of traffic is much higher in case of network and transport rather than the application level. Okay. So if I say what is the major motive of application level DDoS flooding attacks is that these attacks are focusing upon disrupting the legitimate user services by exhausting the server resources. Here, what server resources are we talking about? We'll talk about the sockets, we'll talk about CPU, memory, disk, or database bandwidth, or the input-output bandwidth. Okay. Now, when we say that these are the things which are normally exhausted, this means that the application level DDoS attacks normally consume less bandwidth and are very, let's say, stealthier in nature compared to the ones which are there in the network or transport attacks, because these are the very volumetric attacks. Okay. Um, Now, in case of an application level DDoS flooding attacks, usually the impact is on the services, since they are targeting the specific characteristics of the application layers. For example, it is targeting HTTP, it is targeting DNS, it can also target session initiation protocol, which is SIP. So basically, if we are talking about flooding here, it can be flooding of HTTP packets, flooding of DNS, or flooding of SIP packets. That is session initiation protocol techniques. Okay. So the attackers, which are normally the zombies, generate small DNS queries with the forced source IP addresses. Now, these forced source IP addresses traffic can generate a large volume of network traffic, since there would be a DNS response message generated, which is substantially larger than the DNS query message. Okay. Now, then this entire large volume of network traffic is directed to the targeted system, just to paralyze the entire target system. The other thing which can be there is that the another application level attack employs the reflection technique, which is there in the VoIP flooding, which we had considered previously. Now, this attack is a proper variation of an application specific UDP flooding, where the attackers usually send spoofed VoIP packets through SIP, which is actually part of your application level. So you're using an application level protocol, which is SIP, in a VoIP packet, which is your part of networking traffic. Okay. Now, what would happen is the attackers normally send the spoofed VoIP packets to the session initiation protocol, and when they are sending it at a very high packet rate. When you're sending it at a very high packet rate and with a large source IP addresses range, what would happen? The victim VoIP server would have to find out what is the difference between the proper VoIP connections from the ones which are the forced ones. Now, when you're finding out the actual difference between both of these, it would consume your significant amount of the resources. Okay. So here what is done, the VoIP flooding would completely overwhelm your network with the packets, and these packets would be randomized or the ones with the fixed source IP addresses. Now, if the source IP addresses has not been changed, the VoIP flooding would actually attack the now I'll repeat, if the source IP addresses has not been changed, the VoIP flooding attack mimics the entire traffic from large VoIP servers and can be very difficult to identify because it actually resembles the good traffic. Okay, so what is being done over here? You are exploiting the application level protocol and using it alongside with the protocols of the network and transport layer, so that you cannot actually distinguish that which is your correct traffic, or the server can also not identify the major difference between the attacker's traffic or the regular traffic. Okay, any doubt? I hope it is understood. Now, before moving further with these flooding attacks, uh, let's talk about few defenses which should be employed at this end. Okay, so I told you in the previous class, we can have source-based defense, we can have destination-based defense, we can also have network-based defenses, right? Um, Anybody among you answer me? Deploying a defense is much easier at which end? Is it easier at the source end, or is it easier at the destination end, or is it easier in the network?
Ma'am, there will be
Destination.
Yes. Who's answering?
Destination,
Why?
ma'am, because we only have to protect one server.
Hmm.
Uh, but in the if we apply defense at the source, we have to apply it to every client.
Okay. You'll have to apply it at the end users or at the or at every clients. Okay. So majorly your attack flows are generated at the source end, and when you are having multiple sources, it is very difficult to manually have the defenses. Fine. So one of the defense what we can have is it can either be a source or a destination, but you can have a traditional defense which is there is you can have a packet filtering mechanism. Okay, so you will add a filter which would be programmed similar to how the firewalls are programmed, and the packets are flown through that particular filter. Okay, now when I'm talking about a particular, let's say, defense, which is a source based defense. Okay, now you can have these source based, destination based, network, and hybrid against network or transport level DDoS flooding attacks. Okay, these cannot be used for defense against application level DDoS flooding attacks. Clear? So I'll give you a proper flow. So if I want defense mechanisms to be created, okay, these defense mechanisms can be of two categories. One is based upon deployment location, right, where I would want my defense to be deployed. Second is on the basis of point in time that defense takes place. Here, when I talk about deployment location, so your deployment location can be the one defense against network or transport DDoS, and the second one which we spoke about is defense against application level DDoS flooding. Here, this again, if I want a classification, this can have source based, destination based, network, and a hybrid. This is clear. I guess this is very much clear. If I want it on the basis of deployment location, I can have these four categories. Okay. Now, the other thing which I want on the basis of the packet which is flowing is majorly of an application layer. I can have first one which is destination based. I'll explain all of these in details. Okay, and you can have hybrid. Okay, now the second category which was there is point in time that defense takes place. You can have this before the attack, So you are not sure whether the attack has happened or not. So as of now, you assume that the attack hasn't happened, and then you are trying to develop the defense. Now, this defense can be developed anywhere into your system. Okay. Next is you can have it during the attack, and the third case could be after the attack. Clear? Okay, so what did I say? The first criteria for classification is location, where the defense mechanism is implemented. That is why it is referred as a deployment location. Okay, so on the basis of our deployment location, we have four cases: source, destination, network, and hybrid, or you can refer it as a distributed. And on the basis of defense against application level, we have destination and hybrid, also known as distributed. Okay. Now, the second criteria which we had is the point of time when the DDoS defense mechanism should actually act in response to a possible DDoS flooding attack. So based on this criteria, we classify both the defense mechanisms against the application level and network or transport level DDoS flooding attacks into basically three categories. That is the 3 points of defense against the flooding attack, which is before the attack, that is technically referred as attack prevention, during the attack, which is referred as attack detection, and after the attack, that is attack source identification and response. Okay, so if I would like to move into the detail, I'll first go into the first section, which is classification based on deployment location and based on this. Right? So the first is referred as a source-based mechanism. Here, what you will say, you will employ those source-based mechanisms which are normally deployed near the sources of the attack to prevent the network customers from generating DDoS flooding attacks. So basically, what you can say is that these mechanisms will normally take place at the edge routers of the source's local network or at the access routers of an autonomous system. There you are talking about edge sources, edge routers. So the first defense which can be there on this basis for this source based is first one I will talk about, which is referred as ingress or egress filtering at the sources edge routers. Okay. So I told you about packet filtering. So packet filtering is normally you are adding a filter. It would be programmed accordingly that which packets need to be passed and which packets need to be dropped. Similar to that concept, you have something which is referred as ingress or egress filtering. Okay. Now to explain this, everybody knows what is IPsec. 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 What is it? Anybody?
It's a protocol which gives security to the data,
Okay. What you?
confidentiality, authentication.
Okay. Okay. It is used to send the data. Okay. So now what happens is that your current IP protocol allows your source host to alter the source addresses in the IP packets, right? Now, what that is, it is referred as you can modify the IP addresses into the system. Now, Those packets with spoofed IP addresses cause a huge problem in detecting DDoS flooding attacks. So therefore, your victims cannot distinguish the attack packets from the legitimate users' packets based on the source addresses. Okay, so this problem is somewhat addressed in an IPsec protocol. Okay, what is there in this IPsec protocol so that it tries to prevent all these spoofing? So IPsec is basically something which has AH, has ESP, and IKE. What is this AH, ESP, and IKE? AH is referred as authentication header. So this authentication header tells you or prevents you or has the functionality which is in context to integrity and authentication. So integrity and authentication is part of AH. Fine. Next you have ESP. So this is something which is encapsulating the packet. So which is related to confidentiality. Fine. And the third one, which is IKE, that is referred as Internet Key Exchange. Okay. What is it used for? It is used for setting up the keys and the algorithms for both AH and ESP. Okay. Now, normally what happens is when two clients communicate with each other, they would send the packets based upon the IP addresses, then received by the client, and if it is found that the IP address is same as his own IP address, it would accept the packet. So here what is done is whenever two clients are communicating, they can directly add their IP addresses and send the packets to anyone into the network. Now, this is something which is not advisable for a better network or for a better network communication. That is why the concept of IPsec was introduced. So this says that whenever two clients would like to communicate with each other, they need to agree upon certain factors so that they can set their data confidentially. So for that concept, the concept of internet key exchange has been added. So if A and B needs to communicate to each other, they would agree upon certain algorithms with the help of which they would send the packets, import their data, and they do not want to do further authentication again and again for receiving and sending the packets. Okay, so this IP address spoofing problem is rectified because of the authentication of the source IP, source addresses of IP packets is done in an IPsec protocol. Okay, but this method is not widely deployed among the services which are provided by different network service providers because of its increased overhead. What overhead is there? You have to consider three important factors: integrity, authentication, and confidentiality. You also have to consider that the keys would be exchanged between the clients. You'll also have to consider what encryption algorithms or what public key infrastructure would be set up between both of these. So that is why if you have IPsec as well, it will not always be advantageous because you are trying to prevent spoofing with it, but it is coming with a very high cost of overhead, increased overhead. So, but the concept of ingress and egress mechanism is based upon IPsec only. Here, in case of ingress and egress filtering, the major motive is to detect and filter the packets with spoofed IP addresses. Where do you want to detect and filter it? You want to do it at the source end or at the sources end edge routers based upon the valid IP addresses range to the network. However, these spoofed packets will not be detected if their addresses are still in the valid internal IP addresses range. So let's say if I say that there are two systems, one is host I, which is part of M network, okay, and the other one is host J, which is also part of N network. Hmm. Clear? So what is done? Both of these are two different hosts and are part of same networks. Okay. Now, if a packet is sent out from host I in the network M with the source address of host J, which is also a valid IP address in the network M, clear? What is being done? I is sending a packet to, let's say, outside network N, but it is having the IP address of J. Clear? Now, M and N are registered to each other. It is registered in this case that whatever clients are there in M can send the packets to L, and whatever clients are there in N can send the packets to M. So, if there is any other client from different network and he sends the package to either M or N, they will not receive it. But if a packet which is sent from M to N is sent and it is something which contains these spoofed IP addresses, it will not be able to filter it, or sorry, it will not be able to identify that the address has been spoofed. So, using the ingress and egress filtering with mobile IP users, network traffic from a legitimate mobile IP address has to be tunneled in order to avoid filtering. Moreover, when we're talking about the actual current trends towards employing bots or the botnets to launch various attacks, your attackers can still attack the targets by employing the pool of zombies with genuine IP addresses available through the entire botnets. Okay, so what we did, we were trying to have an ingress and egress filtering within which only those systems can communicate which are registered. Okay. Now, if I only focus upon this thing that any other client which would send the packet, the data to me, the packet would be dropped. But the disadvantage in this case is that if there is spoofing done, which is internally to the network, then you cannot prevent it using ingress and egress filtering. Any doubt? Should I repeat it?
Yes, ma'am. Please repeat it.
Okay. So make a figure which says make two nodes. Okay. Both of these are named as I and J. Done. Your I and J are present in one network named as M.
Okay.
Parallel to this M network, make N network. With that N network, make a node K.
Yes, ma'am.
Clear? Everybody has done it? Now, if I employ ingress and egress filtering, this ingress and egress filtering will be applied towards the incoming and outgoing packets. Okay? अब अगर I से J को पैकेट जाता है या फिर J से I को पैकेट जाता है तो वो पैकेट जा सकता है. क्यों जा सकता है? क्योंकि दोनों एक ही नेटवर्क में हैं. ठीक है?
Yes, ma'am.
Now, if there is a packet which needs to be flown from K to I or K to J, fine. both of these clients are present in different networks.
Yes,
ठीक है,
ma'am.
तो उसके लिए हमको ये फिल्टरिंग का यूज करना पड़ेगा. ठीक है, अब फिल्टरिंग मैंने ऐसे किया कि एम और एन के इंटरफेस पर किया. ये देखा कि अगर कोई इनकमिंग पैकेट है एम पर and that incoming packet has the IP addresses which are part of N network, I will accept them. Here, because M and N have agreed with the IPsec thing. Okay, so there, whatever packet comes from any other network, let's say there is one more network L which is sending the packet saying that this is from N, or it is from a client whose IP address is X. Okay, तो अगर वो वाला IP एड्रेस उस लिस्ट में नहीं होगा तो वो उस पैकेट को ड्रॉप कर देगा, बिकॉज M और N ही अग्री किए हैं, कोई और नेटवर्क अग्री नहीं किया था M के साथ डेटा एक्सचेंज करने के लिए.
ओके
क्लियर?
मैम, अगर वो एल वाला जो है वो के आईपी एड्रेसेस प्रूफ करके भेजे
तो भी वो दूसरे डेस्टिनेशन से भेज रहा है ना,
तो मैम एम उसको ड्रॉप करेगा.
M उसको फिर ड्रॉप कर देगा. तो यहाँ पर क्या हो रहा है कि यहाँ पर डिफरेंट नेटवर्क्स का स्पूफिंग प्रिवेंट हो रहा है, लेकिन अगर कोई पैकेट इंटरनली कोई होस्ट का आईपी एड्रेस स्पूफ करके भेज रहा है ना, वो प्रिवेंट नहीं हो रहा है.
ओके मैम.
ठीक है, फिल्टरिंग यहाँ इनकमिंग और आउटगोइंग पैकेट्स की हो रही है, पर वो नेटवर्क के बेसिस पर हो रही है अगर क्लाइंट रजिस्टर्ड है. लेकिन रजिस्टर्ड होने के बाद भी आपको अगर स्पूफिंग हो रही है, वो आप प्रिवेंट नहीं कर पा रहे हो.
ओके मैम.
ठीक है, एनी डाउट, एनीबॉडी एल्स?
मैम से अगर एल जो एन के आईपी एड्रेस को करके भेजेगा एम को, तो एक्सेप्ट लेगा.
दोबारा बोलो बेटा.
मैम एल एन के आईपी एड्रेस को स्पूफ करके भेजेगा एम को, तो वो एक्सेप्ट कर लेगा.
नहीं करेगा, क्योंकि वो पैकेट एल की उससे आ रहा है, सोर्स से आ रहा है.
ओके.
कोई और डाउट? Let's end today. We'll go ahead with this in tomorrow's class. I'll send you the documents for this. You can go through it and then discuss the doubts. Okay?
ओके मैम.